Hello, welcome back. Today, we want to talk about the asymptotes of rational functions. So our goals, as we can see on the left, we'll be able to find the vertical asymptotes of rational functions. We'll explain what those are, and also be able to find horizontal asymptotes of rational functions as well, and also explain what we mean by that. So a review, a rational function is a function that looks like this, or can be written like this, f of x, where nx over d of x, or both these are functions, both these are nx and d of x are polynomial functions. So it's basically a rational function is a polynomial function divided by another polynomial function. And here, we say that dx can't be zero, the function itself can't be zero. And also any places where dx is zero will be important in a moment. Now, the domain of a function like this is basically, as it says, the set of all numbers such that dx is not equal to zero. So in this polynomial dx, if you have any zeros that function, those places can't be in the domain of the entire function f of x, but any other numbers are valid. So first, let's talk about how to find a vertical asymptote of a rational function, also what we mean by a vertical asymptote. So let's actually make sure we can see our function again. If n of x and d of x, remember, so counting n for numerator, d for denominator, have no real zero in common, basically means they have no factors in common, which can't be simplified, then this function will have a vertical asymptote wherever dx is equal to zero. You notice that's the places where I said can't be included in the domain, because those are the places where we'll have these vertical asymptotes. So vertical asymptote is a straight vertical line with an equation x equals c, where c is a solution to that, where c is a number, plug in, that makes plug in for x that makes this equation equal to zero, or makes your denominator zero. And so the graph then of f of x will approach this vertical asymptote either toward negative infinity or positive infinity, depending on maybe one different sides of the asymptote, depending on the function itself. Now, if you set the denominator equal to zero, and the solution is not real, involves I or something like that, then there's actually no vertical asymptote there. Also, this is really important. A graph can never cross a vertical asymptote, because crossing it, touching it, would mean that you'd be dividing by zero, and that would be undefined. So a graph can never cross a vertical asymptote. And finally, then to find the vertical asymptotes of a rational function, we're going to simplify f of x if possible, then solve the denominator equals zero. Okay, let's look at our first example. And then after we define the vertical asymptote, we'll also talk about the horizontal asymptote. So our first example will be this function. So I'll just say find vertical, abbreviate that, and horizontal asymptotes. Okay, so our function number one, I don't know what that was. A couple issues with my writing pad. All right, number one, let's say we have this. F of x is equal to x squared minus 8x plus 7 and x squared plus 7x minus 8. Now, first thing you want to do, if it's possible, is simplify. In order to simplify, we need to try and factor if we can. If we take a look at this and try and factor, turns out, for this example, we can factor both the numerator and denominator. So our numerator will factor into x minus 7 and x minus 1. Our denominator then will factor into x minus or x plus 8 and x minus 1. Now, if you notice, then we can cancel this out. Okay. Now, careful what this means. Okay. Now, x can't equal 1. If you plugged in positive 1 here, either one, we have 0 over 0, which is something we haven't talked about. We can't do that. Okay, make the denominator 0. But what we can do now is we can actually say that f of x looks like this, x minus 7 over x plus 8. for x not equal to 1. Okay. Now, I want to look at this left and say, okay, what can make our denominator 0? Okay, so to find that, to find our vertical asymptote, what I'm going to do is solve x plus 8 is equal to 0. And that's easy to solve. We just get, of course, x equals negative 8. Okay. So obviously that means that x can't equal negative 8. Okay. This will make our denominator 0. And so then we have a vertical asymptote at x equals 8. X equals negative 8. Okay, so this is the equation of our vertical asymptote. And we'll graph this here in a moment where we can see that. Okay, so our vertical asymptote. What we did, we simplified, okay, where we canceled a factor out. Then we said what will make our denominator 0 is going to be this. And so we'll see the graph is not going to cross this line. We'll have vertical asymptote there, and the graph will either approach this line go toward infinity or negative infinity, depending on the function itself. Okay. Now, let's think about finding the horizontal asymptote. And also what that means. So a horizontal asymptote, so down here. So if the degree of n of x, so the function in the numerator, is less than or equal to the degree of d of x, the function in the denominator, then fx has what's called a horizontal asymptote. Now, if your degree, remember the degree was your highest power of x in each one of your numerator or denominator. So if the degree is less than, degree of the numerator is less than or equal to the degree of the denominator, you have a horizontal asymptote. The horizontal asymptote then is a horizontal line. So let's look at this. Is if the degree of n of x is less than the degree of d of x, so your numerator, degree of your numerator is less than the degree of your denominator. The horizontal asymptote is the horizontal line y equals 0, or the x-axis. Now, if the degree of the numerator is equal to the degree of the denominator, horizontal asymptote is the horizontal line y equals a divided by b, where a is the leading coefficient of n of x, and b is the leading coefficient of d of x. Okay. Also, one more thing. The graph of function can cross the horizontal asymptote near the origin, but it will not cross the horizontal asymptote far from 0, far from the origin. Okay, so now let's look at our function again. Let's just rewrite f of x, the original version. This is what we need to look at. So we have x squared minus 8x plus 7 and x squared plus 7x minus 8. Okay. What we're going to go, these are both second degree polynomials, so they're equal. So the degrees are equal, both second degree. Okay. Now, so the leading coefficient, I'm going to spell, let me make sure I remember to spell coefficients. 2 F's. Yes. Of n of x, the numerator, is equal to 1. Okay. And it turns out then the leading coefficient of the denominator, d of x, is also equal to 1 in this case. Okay. So horizontal asymptote is the horizontal line y equals 1 over 1, which equals 1. Okay. Now, after saying all that, so we found our vertical asymptote at x equals negative 8. and a horizontal asymptote at y equals 1. Now, let's graph this and make sure that happens. So let's go to a graphing site called Desmos. I may have mentioned it before in a previous, maybe seen it before in a previous video. Just go to dsmos.com. It's a really useful site for making graphing calculators. What we're going to do is we're actually going to graph this. Now, to graph a function like this, where we have a fraction, what you want to do then is actually use parentheses. All right, so x squared minus 8x plus 7. Then hit divide. And here we have x squared plus 7x minus 8. Okay, now we need to zoom out just a bit, kind of see what's happening. Okay, now we can also put in a vertical line and a horizontal line, so I'll do both. We said our vertical asymptote should be x equals -8. Right, that's what we see it. So the graph approaches on this side of that, a graph goes to positive infinity, our function does. On this side, a rational function goes to negative infinity on this side of x equals -8. Now, let's also put in our horizontal asymptote, which said it should be the y-axis, or so the line y equals 1. We have to zoom out a bit more to see that. So y equals 1, and that is our horizontal asymptote. As you can see, the graph is approaching 1. Here, it's approaching it from below 1. Here's approaching it from above 1. Now, we said a graph can never cross a vertical asymptote, but it can sometimes cross a horizontal asymptote close to the origin. But out here, it won't never cross this horizontal asymptote. Okay, good. So what we see now is what we expected to see. One horizontal asymptote, one vertical asymptote. Okay, let's go back to do a second example. So this time, let's take a look at our f of x, number 2 equals x over actually, let's make this 3. What I want to make this 3x squared over. I'm changing my mind what I wanted to do, what I had. So, and then our denominator is going to be x plus 1, then x minus 3. Okay. Well, actually, I think I've changed my mind again. Sorry, but it's trying to make sure you see a few different things. Okay, let's take a look at this. Now, let's find our vertical asymptote. And we know to do that. So first, I'll take a look at our function. It's already in factored form. You can see there are no common factors between the numerator and denominator, so we can't simplify anything like we did the first time. Okay, so what we want to do then is we want to solve, set our denominator equal to 0 and solve. So if x plus 1 times x minus 3 is equal to 0. And how to solve this? It's equal to 0 in factored form. Set each factor equal to 0 and solve. So you have x plus 1 is equal to 0. X minus 3 is equal to 0. So we get x equals -1 and x equals 3. So these are our vertical asymptotes, the equations. And these are also the places where if you plug in either one of these, you'll have a 0 in denominator. So these are vertical asymptotes. Now, let's find our horizontal asymptotes, or asymptote rather. All right, and we said, let's just rewrite our function since we can't see it at the moment. So it's going to be 3x over x plus 1 times x minus 3. Okay, now here, up top, we have a degree of 1. And down here, if we actually multiply this out, we see we have a degree of 2. So this is a first degree polynomial. This is a second degree polynomial. Okay, so in that case, we look what we said here. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is just the y-axis. So what happens far from zero is your denominator is going to be bigger than your numerator, and so the whole thing's going to go to zero. Okay. So since the degree of n of x is less than the degree of d of x, then our horizontal asymptote is just the x-axis, or y equals 0. Once again, let's take a look at this on Desmos. Go back. Now here, if you can always turn a graph on or off by clicking on this. So that's what we're going to do here. So in case you want to come back and look at it later, don't have to erase it. So let's graph this. So to graph this, I'm going to use parentheses. So 3x, then divided by, then it was x plus 1 times x minus 3. Okay, now let me zoom in a bit. We can see the details a bit more. Now, let's write in our asymptotes. We said we should have one asymptote at x equals -1, and another one at x equals 3. And that's what we see. So see our graph, in this case, where x is equal to -1, the graph goes to negative infinity here on this side and a positive infinity on this side. Over here, it goes to negative infinity on this side of x equals 3, and it was the positive infinity on this side. And once again, our horizontal asymptote, I'm not going to graph it, just simply it's already there. It's the x-axis. Okay, we see the graph approaches that. Now here we can see it actually does, as mentioned, does cross our horizontal asymptote at the origin, or close to the origin, that's okay. But far away from the origin, the graph will not cross the horizontal asymptote. Okay, let's look at one more example. Number 3. And this time, let's look at f of x is equal to x cubed, oops, make a better 3, over x squared plus 1. Okay, so once again, it doesn't matter which one I find first. I'll just try and find the vertical asymptote first. So once again, to find that, set your denominator equal to 0. First off, see, we can't cancel anything out. Check that, make sure we can't simplify it, and we can't. Let's set this equal to 0 and solve. Now, what's interesting going to happen here, a couple ways you can do this. One way to do it, okay, this won't factor. So you can set x squared is equal to -1. And if you did that, what you would get would be plus or minus the square root of -1, which is plus or minus I. The point here I want to make is that basically this involves I. So this is, its answer is not real. Okay, it's complex or imaginary. So what that tells us then is that there is no vertical asymptote. Because a vertical asymptote occurs because the denominator is going to be 0. Okay, in this case, our denominator can't be 0. We try to set it equal to 0, we got an imaginary number, so your denominator will never be 0. So you won't have a vertical asymptote. Okay, I was thinking about the horizontal asymptote. So for the horizontal asymptote, let's just rewrite our function. F of x is equal to x cubed over x squared plus 1. Let's get once again compare our degrees. So the degree of our numerator is 3, and the degree of our denominator is equal to 2. Okay, so in this case, the degree of the numerator, we called n of x, is greater than the degree of we call d of x, the denominator, in this case, so we have no horizontal asymptote. Okay, so if your degree of the numerator is greater than the degree of denominator, you have no horizontal asymptote. Because the reason you get a horizontal asymptote is basically far from 0, your your numerator and denominator kind of balance. Well, if they have the same degree, they kind of balance out. If the degree of the denominator is bigger than the degree of the numerator, then basically far from zero, the function will go to zero. But here, since the degree of the numerator is larger than the degree of the denominator, this is going to get bigger, a lot bigger as we go from zero. Well, let's going to take a quick look at that graph and verify this is true. So we said we actually had no asymptotes in either case, no vertical or horizontal asymptotes for this one. So once again, I'm simply going to turn these off and scroll down, and we'll do our graph down here. And so here you don't have to use parentheses, but I'll use them for consistency. So x cubed, oops, divided by x squared plus 1. As you can see, right, no asymptote either way, so no vertical or horizontal asymptote. In fact, we can zoom out, and we'll see it's not quite a straight line as you get close to zero, but it's similar to that, okay, far from zero. So basically, once again, no asymptote of any kind for this function. So, really quick review. So anywhere your denominator of your rational function is zero, you'll have a vertical asymptote. You can have one, more than one, or none. And then a horizontal asymptote, if the degree of your numerator is greater than the degree of your denominator, you don't have an horizontal asymptote. If the degrees are equal, basically it's the fraction, the horizontal asymptote is the fraction of the leading coefficient of the numerator over the leading coefficient of the denominator. And finally, if the degree of the numerator is less than the degree of the denominator, your horizontal asymptote is the x-axis. Thank you. Have a good day.